transitioning landfill gas treatment systems for landfills and post-closure monitoring. And a little bit about each of them. So for Alex has a bachelor's degree in environmental engineering from the Florida Gulf Coast University of Fort Myers, Florida. He worked in Florida, South Florida for 8 years, both in local government and private sector. He then escaped to Washington to join Herrera Environmental Consultants in the Seattle area in 2023. His expertise while at Herrera has been in post-closure monitoring and maintenance of closed landfills, including elements of cover systems, landfill gas migration, wastewater conveyance, and stormwater conveyance. Camryn graduated at the University of Washington with a bachelor's of science degree in environmental engineering. She worked as an intern with Herrera during school and joining full-time in 2021. While at Herrera, she was mostly involved in closed and active landfill projects. She has worked on each stage of landfill's lifespan, including permitting, design, compliance, monitoring, and operations maintenance, and landfill redevelopment. I'll turn it back over to you, Alex and Camryn, if you guys can come on up and start the presentation.
All right. Hello, everybody. My name is Alex Erlenbach.
And my name is Camryn Steiner, and we are engineers at Herrera Environmental Consultants. And our presentation for you today is on transitioning landfill gas treatment systems for landfills in post-closure monitoring. So, to start off, when landfills are closed, they fit into 3 overly simplified stages. Early in its closure, there's active treatment, and although landfill gas generation begins to slow, it's still high and can be easily treated with its high caloric value. Then there's the transition zone stage, where landfill gas generation has decreased to a point where treatment options become trickier. This is typically in the 30 to 140 CFM range. Then it decreases even further and reaches a zone we like to call the 30-30 stage, where flow decreases to below 30 CFM and methane concentration decreases to below 30%. On the right here, we have a figure showing this methane decline of a closed landfill. You can see there's a long asymptotic tail it reaches, and this is the target point of our presentation, where you start to transition your system from active treatment stage to passive functional stability. And we discuss flow in units of standard cubic feet per minute, but we have conversions to metric system at the bottom as well. So the process of reevaluation begins when you reach this transition zone and have declining caloric value gas, so the current treatment systems start having problems. To reevaluate your landfill, there's 4 bits of information you'll need to know. These are the loading rates of air pollutants, results of a rebound test, and then of course flow rate and methane percentage. And then these photos on the screen show examples of collecting some of this data in the field. On the right, that's a Landtech GEM 5000. You can hook that up to your collection pipe and get composition data like methane, oxygen, CO2, and you can also get flow and velocity. And then on the left is the process of extracting a sample from your gas collection system into a SUMA canister, and you can send that to lab for analysis of other minor constituents in your landfill gas. So the typical first step in reevaluation is modeling the theoretical conditions of landfill gas generation on a computer. This is typically with the US EPA LandGEM model. It uses the EPA's AP42 compilation of air pollutant emission factors that include default concentration of chemicals. These are used to generate emission estimates in combination with the decay rates of refuse based on site-specific information like type and age of waste. The results of the model then give estimated emission rates for pollutants that you can compare with regulatory emission standards to determine whether destructive treatment is still required.
One of the evolving regulations that's happened just last year was the US EPA's air emissions factors, AP42 list, changed August of last year, which modified the default concentrations for landfill gas. They also shortened the list from 171 constituents down to 47, and eliminating the difference between landfills closed pre and post 1992, excluding for NMOCs. This is used for desktop loading modeling and is a good starting point for chemicals to sample at your site.
Yeah, so while using the AP42 list with the LandGEM is a great tool, it is simply a model, so it cannot reflect exact conditions at your landfill. So the best way to determine current landfill emission status is by grabbing a landfill gas sample directly from your collection system and sending it to a suitable lab for analysis of constituents of concern that have been previously defined for your landfill, or that are defined by your regulator. We in Washington use the Washington Administrative Code's toxic air pollutants, or TAPs, and we've included similar regulations for Oregon and British Columbia. After you get your lab samples results back, you can dive into your emissions analysis. We have the Washington State procedure listed here. First, you'll calculate loadings or emission rates using the concentrations from your lab, and then the flow rate of your system at the time of your gas collection. And then you'll compare the loading rates to the regulator's emission thresholds. For Washington, these are small quantity emission rates. In Washington, if these loadings are below the small quantity emission rates, then you're in compliance and don't require destruction. But if the loading analysis finds that certain compounds are in exceedance of these emission thresholds, you can model plumes and determine the diluted concentration at public receptors using the US EPA air screen program. You can plug in your loading rates along with other site-specific information to see what the concentrations of these pollutants are after they've been diluted. The regulators then have acceptable concentration levels for these analytes. For Washington, they are acceptable source impact levels that your model diluted concentration results should be compared to. If the modeled concentrations are at or below acceptable levels at the property boundary, or where people might come into contact with your plumes, then destructive treatment would not be required.
So for anybody who's had to do loading rates, you typically use the US EPA air screen model. For those who have used that, know that it is slow and cumbersome. So we at Herrera created an automated tool consisting of an Excel file and a website, which helps you automate the running of the model. You input your data into the spreadsheet, upload it to the website, and run the model much quicker. It is currently only an internal tool, but if, fingers crossed, we can get to Archon and do a demonstration, or you can give us a call and we can do one for you there.
So after determining if destructive treatment is still required for your site, the next step is determining whether active or passive collection is required, and you do this via a rebound test. A rebound test is essentially when you turn off active collection to your system, convert it to passive, and assess whether that's enough to keep landfill gas from migrating from the landfill via soil, air emissions, or through groundwater. This test is only a possibility if historic migration monitoring data has indicated that there's been no landfill gas migration under the current active collection system. And if a rebound test is approved by your regulator, monitoring frequency should be increased to assess how or if levels change during this change of operation. And if monitoring levels before and during the rebound test are similar and below regulatory thresholds, indicating that migration is not occurring, there's a case to be made that long-term passive collection is possible for your site. So as I just mentioned, one of the ways to confirm if a rebound test is working is by performing surface emissions monitoring across your site. Recently, the state of Washington strengthened their surface emissions monitoring requirements for landfills that received waste after January 1st, 1992. These changes included reducing the monitoring interval, making the window tighter for monitoring with stricter weather conditions, and corrective actions are now required at lower ppm values. This is all just to mention that even if you have a closed landfill with decreasing caloric value gas, the emissions requirements have been getting stricter, so it's still very important to properly collect and treat this gas.
All right, so at this stage, your options are getting into focus. You know if you need active collection or just passive venting, and you know if treatment is or is not necessary. We've got a grid of options here that'll eliminate what you need to do, or show what you need to do, and we'll go into more detail as we continue. The next piece of information you'll need is the flow rate and methane to help narrow down your options further. Your passive flow rate is the natural venting of your site, and typically we see up to 75% reduction from active collection flow. The active collection flow must strike a balance between not overpulling while also preventing migration. Once you've optimized your flow rate, you get your methane percent. Though regulations differ, we recommend doing some sort of treatment or dilution if methane is at or above 5%. Here we have graphed an incomplete list of different treatment options based off of flow on the x-axis and methane percent on the y-axis. We can zoom in there. Starting at the top left, you've got your classic tiki torch flare. You've some models capable of very low flow and low methane percent, even lower if you provide supplemental fuel. Then there is the Stirling piston engine, which is a novel technology that we learned about 2 weeks ago at a SWANA presentation that we thought we'd throw in there. There's the classic enclosed flare further right, and then the money zone in the green there for using your fuel as, or using your methane to process for fuel or energy. Then at the bottom left, there's the 30-30 zone, which we've intentionally obfuscated for dramatic effect. We'll get into further along. There is the small thermal oxidizer that uses supplemental fuel to destroy landfill gas, the large thermal oxidizer that uses electricity for destruction, and the granular activated carbon GAC canisters of up to 2,000 pounds to treat gas with high contaminants and high flow when flaring isn't viable. These are some sites that we have worked on that use this technology. Zooming in on the 30-30 zone, that's when flow is at or below 30 SCFM and methane is at or below 30%. Flaring becomes less viable, so we recommend alternative methods. The viability of the treatment option is based off of the loading rate, the flow rate, and the methane percent. So you can split it up here into whether or not treatment is or is not required. If treatment is not required, you can simply do venting with or without dilution, depending on your methane percent. If methane is too high, we might recommend a continuous ignition sparking flare to burn any buildup. If treatment is required, there's of course the supplemental fuel flare, but that's a losing battle. Eventually you'll need something else, and so we would recommend a bioburn. We are showing the viability of bioburns at different volumes of material. A bioburn is a bed of compost material that breaks down methane. They are viable at larger volumes, but are dictated by how much space you have available. We've got a chart here showing at 4 feet tall, the total area that would be necessary. So if you've got a football field of space, then you can treat a lot of gas, but if you can't, then that's not possible. We have seen in some instances an entire landfill cover system being converted into a bioburn, which can treat a lot of gas, but it all depends on how much space you have. So to summarize, we've got a list of recommendations. Reevaluate when your system gets below 140 SCFM or methane gets below 30%. Conduct your rebound test and your loading analysis to see if you can do passive or require active collection and if treatment is necessary. When you convert to passive, you'll see an up to 75% reduction in the flow rate of your gas. You want to treat your landfill gas when it is at or above 5%. And if you don't want to know any of this stuff, you can give us a call and we can help you out. And, that's how you get a hold of us, and that's all we got. Thank you very much.